Hello, welcome everybody to your lesson on surface area and volume. This is Unit 6.2, surface area and volume. This should be a pretty much refresher. It should be pretty easy. The slide you see in front of you is the very first part of the worksheet that you're going to do. So you can either go back and look at these and fill them in once you get the worksheet, or you can put them in your notebook and then put them back on the worksheet when you're ready. As you look at this, I would probably encourage you to attempt to try to do these problems on your own, for example, like looking at this first one. What's the equation for the area of a rectangle? Well, it's just length times width. What's the equation for area of a triangle? If you want to pause the video and attempt all those, feel free, but we'll be using all those in a moment. So area of a triangle, 1/2 base times height. Area of a circle, pi r squared. What is the equation for the surface area of a cylinder? Surface area is 2 pi r squared plus 2 pi rh. The volume of a cylinder is pi r squared h, and then the equation for the volume of a sphere is 4/3 pi r cubed. There are some more formulas down here that I just kind of gave you. You'll need to know what all these letters stand for. For an example, like R is the radius of a circle, so it's from the middle to the edge. Height of a cylinder, that would be how tall the cylinder or the can is. So those are the things you need to know. So as we move in, here's example 1. The very first thing you're going to have to figure out is you're going to have to figure out what kind of shape it is. Well, this one is a cylinder. Hopefully you know what a cylinder looks like and you're able to identify those shapes. There's kind of like a hidden circle on the bottom here. And I'm going to do two things with this cylinder for example 1. I'm going to find the surface area, and then I'm going to find the volume. So let's start with surface area. As I find the surface area, I go to that formula page, and the surface area for a cylinder is going to be equal to, I'm going to copy down the formula, it's 2 pi r squared plus 2 pi rh, and I'm going to fill in the numbers. It's really simple. 2 is a 2, pi is a pi, 3.14, r in this case is the 6, so it'd be 6 squared, plus 2 times pi, the radius again is 6, the height is 14. And you work all that out. 6 squared is 36, 36 times 2 is 72, and 6 times 14 times 2 is, I believe that's 168, and then 72 plus 168 gives me 240. It is acceptable to leave your answer in terms of pi. This is one acceptable answer, 240 pi. Now if you use the pi button on your calculator, you can certainly convert it into a decimal. I believe it's 753.9822. And the units on these, since the units are centimeters, this is area, surface area, it'd be square centimeters. That's how much material I would need to paint this object if this is a can or something like that. Volume, using a different formula. Volume for a cylinder, going back to that first page, is pi r squared h. And you just plug in your values. R is 6, h is 14, 36 times 14 times pi. 36 times 14 is, I believe that's 504 pi. And then volume has a unit of cubic centimeters. If you wanted to put in 3.14 for pi, this answer, I believe, is 1583.3626 cubic centimeters. And there you have it. It's a quick little cylinder problem. Pretty easy, just regular standard geometry stuff. You're going to get to more complicated ones like this. This is defined to be a triangular prism. Prism because it doesn't come to a point like a pyramid would, but triangular because the bottom or top, this dotted section here, is a triangle. So the bases are triangles. So when you do the surface area of a prism like this, sometimes if it's a box, it's just, you know, length times width times height if you're doing volume. But in this case, we're going to start with surface area, and we're going to do the surface area is how much area each of these sides takes up. Now this is going to be a tricky one because the sides are all different size shapes. So I'm going to start with the very polka dotted one, which is the top and the bottom. Those are two triangles, so I'm just going to write myself a note, two triangles, and then I'm going to add it to rectangle 1, rectangle 2, rectangle 3. I don't think they have the same areas on each of those rectangles. So a triangle has an area of 1/2 base times height. The B in this case, base is going to be the side perpendicular to the height. When I had those drawn in, you could see there, these two darkened blue lines are base and height. Anytime you have a triangle, you have to have right angles for your base and your height. That would be your base, that would be your height. So for this bottom one, even though this one right here is not a side, it's still the height of the triangle. So 1/2 base, which is this 5, since this is 5, this is 5, so 5 times the height, which is 1.5. So I think I did that somewhere here. 1/2 times 5 times 1.5. I think that's 3.75. Let me just check that out. 1/2 times 5 times 1.5. This is 3.75, and then you have to double that because there's a top and a bottom. So that would be 7.5. Now that's just the top and the bottom. Then I need to do, let me get my eraser out here, let me kind of erase all this. Then I need to do a side. So I'm going to pick, the first side I'm going to pick, and change colors here, I'm going to do this front side right here. That front side is a rectangle, length times width, 4 times 4. So 16. Excuse me. Then I'm going to go to black. This left side over here. That is 2 by, how tall is that? Oh, and there's not a side length over there, but this is where I go. So it's a 2 by 4. So you add 8. And then I'm going to go to the back side, which is be way back there. That's a different rectangle. That would be 5 by 4. 5 by 4. So plus 20. So 16, 8, and 20. So then I take 7.5 plus 16 plus 8 plus 20. You have to break up surface area if it's not one of your formulas on the front. So when you do all this, I believe it ends up to be 51.5. Units, in this case, are yards, but it's surface area, so it's square yards. Then we have to do the volume. Okay, a volume of a shape like this, I like to write this in my geometry class as a capital B times H. Capital B represents the area of the base. In our case, the base is a, trying to erase all this here, the base is a rectangle. So what I need to do, is a triangle. So what I need to do is I need to find the area of a triangle. So I think I did that already somewhere. So let me just kind of take a look at this. So the triangle I have on the base is this bottom one here. So that is 1/2 base times height, which is 5 times 1.5. And then multiply that by the height. The height of the entire object is 4, because I'm summing up an infinite amount of these triangles until I reach the top. So there's another one, and I stack another one on top, and I keep stacking, I keep stacking, I keep stacking them 4 high. So all I have to do is multiply this all out. So 1/2 times 5 times 1.5 times 4, I believe that gives me 15, and in this case it's cubic yards. And then moving on to my last example, example number 3 is a cone. So I go back to the The formulas on the front, I'm not going to do a sphere. That's for you to do. Sphere's like a ball. But those formulas are on the front also. But for the volume of a cone, the volume formula on the front is 1/3 pi r squared h. So let's just do the volume of this cone. 1/3 is 1/3. R is the radius. In that case, it's right there. That's a 2, so it's 2 squared. Height is 3. So pretty simple. 2 squared is 4. 4 times 3 is 12. It's 12, and it's a 1/3 of 12. 1/3 of 12 is 4. So in this case, it's 4 kilometers cubed because it's volume. Then I'm going to move to surface area. Now, surface area is a little bit more challenging here. I'm going to go back to the formulas on the front. Surface area of a right cone. This is a tricky formula. It's probably your hardest one. Pi r, then there's an L. L is a slant height, tells you that on the front, plus pi r squared. The r is real simple. The radius is 2. 2 squared. That's going to be 4. Then this is a pi, and this is an r. R is 2. Here's the tricky part, slant height. Slant height is this height right there. In this problem, I don't know it. The 3 goes to this middle part here. That's the height of the cone. So I know that's a 3, but I still don't know what this side is. However, if I look at it, I've got my good old friend, the right triangle here, and I could use Pythagorean theorem, a squared plus b squared equals c squared. C in this case is my slant height, my unknown, so L or C. The A is 2, the B is 3. So 2 squared is 4, 3 squared is 9, you get c squared equals 13. And then you take the square root of both sides, c is the square root of 13. I'm going to leave that in here as a square root of 13. Because there's a couple ways you can write this. You can write this as 2 square root of 13 pi plus 4 pi. Now there's really no way to simplify that. But if you wanted to plug in your 3.14, you're certainly welcome to, and I believe the correct answer to this, plugging in 3.14, is 35.2207. Now this is surface area, so this is square kilometers. That's it. This is just kind of formula plug and chug. Good luck, and thanks for listening.